Good morning.
Yeah, absolutely. I should have put notes as well.
And thank you for joining us this morning for our session today, how Viasat uses AWS AI to customize algorithms for satellite customers. I'm Andre Kearns, Marketing Director for AWS Aerospace and Satellite. We have a lot that we want to share with you today, so let's jump right in. So here's the agenda that we're going to cover today. First, I'm going to provide a brief overview of the massive satellite data challenge that the global space industry faces. And I want to do that as context for the role of data science across the industry. I'll then introduce how AWS is helping our customers to meet these big challenges. And we're doing that by providing innovative solutions tailored to the global space industry. I'll then introduce our terrific speakers for today. And so we have leaders from AWS and Viasat who will come up, they'll introduce themselves, they'll introduce their role, and really share how they work together to advance Viasat's satellite communications mission to connect the globe using AWS. And to close things out, we'll open up the floor to answer your questions, right? That's the fun part. And just as a final reminder, we are recording this session right now. And so this session will be available to you all on YouTube, I would say within a week. A recent report by space industry analyst NSR projects that 52 exabytes of space data will be transported by satellite networks by 2029. 52 exabytes. Now, to put that astronomical number, that pun was intended, to put that astronomical number into context, 52 exabytes is more than 10 times the amount of words that have ever been spoken by every human being that has ever existed. This massive growth in space data really underscores the growing role of data science in driving the shape of the future of the global space industry. So our ability to capture, to transmit, and to analyze exabytes of space data is really going to unlock amazing innovations that will benefit our society for years and years to come. And so this is our challenge, and it's also our opportunity to develop and apply good data science methodology, AI, ML, advanced data analytics, to be able to extract valuable insights from this massive space data, and to be able to do it reliably, and to be able to do it rapidly in a timely manner, and to be able to do it at scale. Solving big challenges like this is why we created AWS Aerospace and Satellite as a business. And so every day we work with our customers to help them to reimagine their space systems, to automate their data space workflows, to accelerate innovation that they're driving, and to ultimately improve the outcomes from their space missions. And so we do that by delivering innovative solutions that are really designed for the industry and really designed to lower the traditional barriers associated with space, whether it's latency issues or network bandwidth limitations or traditional lack of access to scalable data infrastructure. And so here are examples of how we're working with our customers every day to apply cloud-based AI ML to massive amounts of space mission data to enable industry success and to enable mission success. We have extended edge computing into space. And that's allowing our customers to analyze data in orbit to save time and money. We're automating space data workflows, allowing our customers, again, to deliver faster time to insights and extract and realize much more value from the data that they're collecting. We're expanding our connected world with customers like Viasat, using services like SageMaker, which you'll hear a little bit more about in this session, to detect anomalies and improve satellite communication network reliability. And finally, we're helping our customers to transform their space systems to optimize planning, performance, and safety. And so with that as context, I'd now like to introduce our speakers. So first, I'd like to call up Claire Zoe-Price, who's Customer Solutions Manager for AWS Aerospace and Satellite. And then after she talks, she will introduce Sumit Singh, Chief Development and Data Officer for Viasat. And with that, over to you, Claire.
Thanks, Andre. Hi, everyone. I'm Claire Zoe-Price, and I'm a Customer Solutions Manager supporting the AWS Aerospace and Satellite vertical. Raise a hand if you know what a CSM does. Okay, good. I thought so. So I thought it may be helpful to start with an introduction of my role so you get why I'm here and how I support customer success. So the CSM in AWS is an AWS investor role that works as part of the account team to provide a consistent and unified support to our customers. Although AWS is a technology company, we understand it takes more than technology to solve a business problem. Agree? Right. It involves identifying and understanding the underlying root cause of the issue, selecting the right technology, building readiness around the people and the process, implementing the solution, and managing change before the problem is solved in the most efficient manner. The CSM is a certified solutions architect and a certified project manager that takes this problem-solving approach to help our customers removing blockers in every step of their cloud journey. So how does a CSM do this? You may have heard of the empty chair concept in AWS, which may sound a little bit cheesy, but I tell you it works. So when we have internal meetings, we'll put an empty chair like this in the room to remind us of the customer, remind their real needs, and to guide us to make the best decision for them. The CSM works very closely with the customer and serves as the voice of the customer in these meetings when the customer is not present. And you may also have heard that 90% of AWS products, features, and services come from customer requests, which is true. The CSM is that enabler of the feedback loop to ensure that customer voice and customer requests are captured, properly documented, prioritized, and finally productized into our offering roadmap. Viasat is a strategic customer of AWS and a very important customer which I support. Viasat, is a vertically integrated company that operates on a massive scale, from manufacturing their own satellite communications equipment to operating their, geostationary satellite fleets in space, and offering satellite communication services such as broadband and mobile directly to customers all over the world. Viasat is one of the first movers to the cloud in the space industry, and they operate mainly on AWS. The culture of Viasat is similar to what we have at AWS. It's a company that's made of builders, where everyone shares the similar mindset of continuous innovation and improvement. I've had the pleasure to support a few bright minds within Viasat. To name a few, the Director of Machine Learning, Sean Austin, the Senior Director of Enterprise Architecture, Mayur Savla, right? And Senior Engineering Manager, Matt Butler, Software Engineer, Mark Sadell, and the list goes on. I helped Viasat recently to build a real-time data and machine learning pipeline that ingests terabytes of telemetry data generated by satellites that are orbiting more than 35,000 kilometers away from Earth on a daily basis to perform advanced network analytics. In response to Viasat's cost-cutting initiatives, my team, with the support of our account executive, Hayes Magnuson, and our ANS leadership, we were able to, engage in and proactively engage in a series of activities to help Viasat to reduce 40% of their overall cloud spend to date. In addition, and in parallel to, the machine learning pipeline and cost optimization effort, we're also supporting Viasat in designing and building a fault-tolerant cloud architecture with the goal to improve their service availability and resiliency using services such as AWS Backup and Resilience Hub. I'm going to play a small video that will help you to understand Viasat's business better. So, do you guys notice anything in the video? What did you see in the video? You see the customers. It's not about Viasat. It is all about their customers. And I can testify that. That is something we have in similarity as well, is that we're extremely customer obsessed. Viasat is no exception. And they are passionate and proud of what they're doing, the changes they're making, how they're unlocking opportunities for every person living on Earth, no matter where they live. So the focus of today's presentation is about Viasat's success story in building a machine ops pipeline using AWS services such as S3, Kinesis, EMR, and SageMaker, and etc. And the empty chair here today represents the Director of Machine Learning, Sean Austin. From my experience of working with Sean, he really impressed me upon as someone that's an expert, has an expert understanding of technology trends and the appropriate application of building innovative solutions that drive customer value, that's impactful, that's measurable. Sean's passion is contagious, actually. He inspired the account team to unite with multiple service teams to deliver above and beyond his measuring, his benchmarking statistics, so we can make this happen. Unfortunately, Sean can't make it on stage today, but for a very good reason, though. His son, Lucas Austin, is representing the United States of America to compete in the ISA World Junior Surfing Championship in Brazil as we're speaking. We're very happy and proud for Lucas, and we wish him the best of luck in winning the championship for Team USA. While we were missing Sean, we had the blessing to invite another very impressive person, in my opinion, to share the story with this audience, which is Sumit Singh. Sumit is the Chief Data and Development Officer of Viasat, who is a visionary, a strategist, a certified search and rescue diver, and a great storyteller. Please join me to welcome Sumit. Thank you.
Thank you, Claire. That was awesome. So as you can see, we work super close with AWS, and our partnership spans many years now. Just out of curiosity to tune the dialogue that we have this morning, how many of you represent sort of space or satellite industry? How many of you are familiar with that? Quite a few. Okay, that's good. So again, this is not a deeply technical talk. I think the key takeaways here are the challenges we faced. And you're going to face many challenges. Machine learning operations was one of our challenges that we'll talk about here, that we partnered with AWS very, very closely on. We didn't have that DNA in the company. We did a lot of machine learning, don't get me wrong, but I do think that the challenges, as you will see them, were pretty unique. And we obviously leaned in on AWS as SageMaker was becoming popular to try and build a platform out of it for the company, and a common blueprint that everybody can leverage, the entire organization. So a lot of the takeaways about those challenges, and you may relate to some of those in your organizations, and then our approach to solving those and what we saw as results or benefits from those approaches. So I think that's really, I would say, is the key takeaway in this presentation. I'll just quickly give you a bit more of who we are, what we do, how we do it. And then we'll get into our use of AWS, what does the footprint look like, and then we'll get into the machine learning use cases. As I said, we'll talk a lot about the machine learning operational challenges we had, how we sort of built a platform around SageMaker to solve those challenges, and then where we're headed next. So that's kind of the outline, and hopefully we have plenty of time at the end. So Viasat, we're a little over $4 billion in revenue. We recently acquired Inmarsat, so this represents the combined view of the company. We have about 19 satellites in operations globally. These are geosynchronous satellites, and we have 11 other in construction. And we cover all the way from K-band, L-band, S-band. And then 2 of these satellites that are under construction are the HEO orbit satellites, highly elliptical orbit satellites. So a pretty decent fleet that covers the entire globe and provides millions of connections all around the world. We're in existence for nearly 40 years now, believe me on that. And we have evolved as a company in terms of where we're today, about 7,000 employees, 90 offices globally, 90 plus, I would say. So that's really who we are. And if you look at what we do, we serve certain key markets, right? And mobility markets is predominantly one that we cover pretty well. So commercial aviation, business aviation, energy services, enterprise, land mobile, et cetera. And then government is the other substantial business we have, where we cover military, Department of Defense, et cetera, tactical operations. And then finally, the fixed broadband market, which is home, consumer, internet, communities, and businesses. So that's what we do. Now, this is important to understand as we relate to some of the machine learning work we did with AWS. We are a company that thrives on innovation, so small but a pretty innovative company. We constantly try and push the boundaries of the satellite bandwidth that we can obtain from the technology, and then really optimize the use of that bandwidth across the globe. So a really hard problem. And that end-to-end performance improvement is what we try and pride ourselves on. And as Claire was mentioning, we're a vertically integrated company from a legacy Viasat standpoint. We're a vertically integrated company, which means we try and optimize every layer that we touch, all the way from the satellites we build, try and push the bandwidth boundaries of what it can do for us, to I would say, a network or service that operates largely on cloud environments. And then our terminals, which optimizes performance on the ground through those services that come through satellite. And then ground stations as well, where cost efficiency matters with a global footprint. And then customer operations and touching everything that touches our customers, right? So we try and optimize each of these layers. And so speaking of cloud, as I said, a lot of this infrastructure is in cloud. We've been using AWS for a while, and believe me or not, our recent sort of stat on the number of distinct AWS services we use was over 150, which means we pretty much use all of them. If you think about the classical services we use, a lot of EC2 consumption, a lot of RDS consumption, a lot of storage consumption, ton of data transfer every month. And then we are slowly shifting over to other services now. So we're moving a lot of our applications, containerizing them, starting to use Elastic Kubernetes service, converting a lot of our workflows with Lambdas. SageMaker usage is picking up. So we're moving to some of the newer services as AWS is introducing them. And speaking of AWS and speaking of data and speaking of some of the optimization I talked about that sort of is at the crux of our business, we have a lot of machine learning use cases, 125 data scientists across the business. And if you look at the sort of the lower two layers, that's pretty common across all businesses, regardless of which specific industry the business operates in. So these are more internal operations or external operations type use cases. Quality of service matters a lot to us. A lot goes on there. I bundled it all in one. But it's an extensive area where a lot of different models play. And I think cybersecurity is another area, given we do a lot of government business. That's a really important facet for us, for Viasat. And then both our ground networks and space networks, and that's kind of the other two layers that I'm talking about here. There's a lot of machine learning work that goes on in every aspect of our ground network, in every aspect of our space-based operations. We're operating a hybrid network, a global network, and trying to optimize a lot across that network. So you see, Andre talked about anomaly detection as an important use case in the satellite industry. We're trying to push the boundaries there. We're trying to do automated root cause analysis with real-time data. Claire talked about some of the recent efforts that we have in turning our data platforms to as real-time as they possibly can. And one of the drivers is for building a platform like that is to do auto remediations, where we don't have to intervene as issues happen. And I'm not even talking about the application layer here, such as, say, for example, we provide in-flight connectivity. It's an entire edge stack, a ground stack. It has front-end portals and advertising and media, television, et cetera. I'm not talking about any of that. They all have machine learning use cases. So the data platform that we built on AWS is important, and the machine learning we've done, I think, is good. But along the way, I think the teams have diverged a lot historically. If you look at the approaches the teams have, they were all quite different, right? They were all doing different things. There was no standard tool. I think there were a ton of difficulty. I'll talk about that next. There was no consistent framework. There was no consistent inferencing layer. And every team sort of ran in different directions. And I don't think that was ideal, right? So that's where we were. We do a lot of machine learning. But the key challenge is really where to take those algorithms, take those proof of concepts, and productionize them. And productionize them in a way that you don't need to touch them. And so really what we wanted was a standardized environment, a common blueprint for the company. Right? That didn't exist. We needed a solution that seamlessly scales. And then we wanted these processes to be repeatable. As you saw in previous slides, what the teams were doing were largely ad hoc, right? Sometimes you wouldn't be able to repeat them, automate them properly. So it created a lot of bottlenecks. Particularly, we were really good in building models, still are pretty good in building models. I think where we weren't as good was to take those models into production in a way that becomes touchless and everything works the way they're supposed to work. So those were sort of where we wanted to go, those dimensions that I mentioned. But we had custom approaches. When I say custom approaches, people were selecting tools differently in different business units. I think there was a lot of what I call as open source based approaches that were semi-optimal, et cetera. Our environments, particularly when it came to training time or hyperparameter optimization, took a long time, right? So these environments were, even if scalable for data, weren't quite scalable for MLOps. Repeatable MLOps, I'm continually talking about that because that's the key challenge we're trying to highlight here. Not that we didn't do good machine learning, not that we didn't build good models. It was just that those models weren't giving enough value to the organization. And then finally, I think a lot of these tools that different business units had down selected often lacked advanced features, right? So we just didn't keep up with the pace of innovation given the fragmented approaches across the company. So those were really the key challenges, and that's where we weren't getting enough value from all the data science efforts that we had across the company. So what did we do? Obviously, there was a need to accelerate MLOps in the company, right? So we clearly recognized that that's necessary. And we didn't really have, I think we were pretty good as far as data platforms and operating a large-scale platform is concerned. I don't think we had the MLOps DNA. So what we did was to accelerate it, we partnered with AWS, right? And 3 specific teams, as you can see here. The solutions architecture team, and I think that provided a lot of really good input. The training team to do a really good training on SageMaker and then the MLOps approaches, and the pro services team. So we created a joint Tiger team, which I think was really good because a lot of that knowledge stayed with Viasat as we approached some of the MVP use cases, and I'll talk about that. SageMaker best practices, training around that, professional services, it all sort of came in as part of the plan we put together for accelerating MLOps transformation. We did design, so SageMaker has been evolving, as you guys all know. We did co-design a serverless platform that we kind of called our ML platform based on SageMaker, and I'll show you glimpses of how we do different things there. And then, as I said, our challenges were training times, time that we were spending in hyperparameter optimization as multiple variants of models came through the shop, which one to pick, et cetera. Those were really the key challenges. So our focus was to solve those, the handoffs, essentially. Not that specific, I think the specific steps were pretty good. It's just that we were breaking down in the handoffs, and it happened. From data science all the way, or data scientists building models, trying things out, all the way into actually serving production traffic. And I think the point 5 is also important. When you do a transformation like this, when you do a change like this, I think it's important to have a big use case behind it. to drive that use case through the transformation, through the process, to really sort of test it. Does it work? Does it work for one of my big use cases? Is it going to work for everything else? And impressively, we did this entire thing in about 14 weeks from start to finish. So let me give you a bit more. So it's a summarized plan, not a detailed plan, but we spent the first few weeks really understanding the technology, the architecture that was necessary for us based on our requirements. We did a data lab and really took this concept of industrializing ML across the organization. So that was the focus, right? How do we spread this blueprint across the organization? What is it that we need to build that satisfies everyone? And we eventually finalized a plan, finalized a solution architecture, and then, as I said, took that MVP for most of the period. And with this MVP, the real challenges were it's a very complicated model. It's in our fixed broadband business. The real challenges there were that we just weren't updating them fast enough. We weren't updating that model often. We weren't applying all the additional data sources that we had in the company since that thing was introduced. And there were a lot of reasons for why it wasn't being up to date, wasn't being kept up to date, et cetera. So we refactored the entire code using Lambdas. As I said, Lambda is something we've started to use pretty extensively. Refactored the entire code base using Lambda, implemented this ML platform for that use case. And I'll show you some results at the end in terms of what it looks like now, having gone through this process. So that's really what the plan was, to accelerate this journey and drive for standardization and that blueprint that I'm talking about. As I said, training, people often ignore this, the importance of infusing new knowledge in the company when that doesn't exist. And so SageMaker, of course, we didn't really have a lot of deep knowledge in the company on it. And we were, as I said, really good in building models, really poor in productionizing them. And so training was important. As you can see, there was a lot of focus on first part was an online training, but the real on-site trainings were all about DevOps and MLOps, which is where we were focused on. And these trainings did help a lot in that acceleration, in creating that knowledge body in the company, which still exists. And now we have, Claire talked about certifications, et cetera. So we've certified engineers now on this. Obviously, you've seen a lot of talks here last year on SageMaker and everything that goes in there. Unified web portal, a consolidated environment with all kinds of things. You have data wrangler, you have facilities to do training, you have facilities to understand model drifts, you have facilities to understand bias. So it's a comprehensive environment. But there are a few things that not a lot of people know deeply about, that it's customizable. And so one of the things we did with SageMaker was created a custom kernel that can bring our Jupyter Notebook environments, our sort of auth scripts, our PySpark attachments, our sort of, I would say, APIs, not quite APIs. These were libraries that can hook up to our data sources in SageMaker. So this SageMaker now looks like a Viasat SageMaker customized for things that are, I would say, unique to our environment and our systems and how we've done things historically, right? So that aspect of SageMaker, I think, became important for us, and I did want to highlight that. Not a lot of people talk about that. Moving on, so this is an example. I talked about creating blueprints. So this is one of those blueprints for model training pipeline. And as you can see, I don't know if it's a bit hard to see if you follow the numbers. So this is an example where we have one of the Devik data science accounts. And you can see the activities that happen within the data science accounts, how it connects to our code repository. And so those are some of the customizations in the platform that I'm talking about, and kind of goes through the normal cycle of training. The SageMaker pipeline, as you see in the middle, from that data science account. And then we make extensive use, and I'll explain that in a bit, of another small service that doesn't get often talked about, which is EventBridge. I don't know how many of you are familiar with it, but it's a pretty nifty little service to build event-driven applications, so make extensive use of that. And I'll show you how we orchestrate this ML platform, given the requirements we had in the beginning. And that eventually triggers, that EventBridge eventually triggers the whole life cycle flow, that handover that I was talking about. And so hence it's important, small little service, but did want to highlight that we had breakages in the process, and I think we wanted to fix those. And so that's a little service that actually comes to rescue, along with things we've done with SageMaker, of course. So maybe enough on this. Let me talk about the philosophy or the approach. I think this is important, and this is something we did which I think is unique. So we divided up the platform in few environments, depending on where the breakages happen, right? There was a data science account. This is where predominantly people test things out, look at data, validate it, actually build a model. But they don't do more than that over there. And so it has hooks into few of our sort of systems, but not the overall system, not the overall application. And you can have a single VPC, you can have multiple, however you want to set it up. And then we have a second sort of core account in the platform, which is for dev and QA tasks. And then they run in separate VPCs. And if you think about that, that then starts to integrate with other environments so that you can test the system end to end. And so those integrations come pre-built from the platform. A lot of that repeatable work was sort of, we tried to take care of all that repeatable work in that SageMaker-based environment through this account orchestration and EventBridge. And then finally, the prod account, of course, prod and non-prod run separate VPCs, but they're somewhat isolated. And really, the intention was to get to that carrier-grade deployment of the models that we missed before. And this flow of how we, brought the models into the operational world helped us. If I talked about the MVP, I'm going to tell you about some of the results we saw as we took that through this process. It's a very large model. Some Viasat people here must be familiar with that. And this model is complicated. It's also old. The code is really old. And so we really wanted that, given that it was contentious at that time in the company about its state, its value. We wanted to take that through the process. And so obviously we worked, as I said, part of the plan, the 11 weeks we spent with AWS was mostly on refactoring this code, right? So we moved the environment, first of all, to the SageMaker-based platform I just talked about. And then all the training pipelines were shifted over to the SageMaker pipeline. And I think our training time was down from like 20 plus hours to minutes. Obviously, this is a serverless platform and scales pretty well. We had a lot of limitations in our prior deployment of that model. So it was a huge, huge gain just in that training step and hyperparameter optimization step. And then the multi-account orchestration I just talked about, we actually took this MVP through that setup to test things out, to see if it's onerous, if it's not onerous, and we have specific ways of provisioning accounts. Again, been doing this for a long time, so there are security principles we apply on top of things that company cares about, et cetera, right? And then there was complete observability as to what was going on with this model through CloudWatch and other means. And then finally, we didn't really have a very good blue-green sort of deployment philosophy with this model. And I think we do have now, right? So now we barely touch this. It updates itself. Since we have done this work, I think we've updated this 30 plus times already. Or we had difficulty updating it once in 6 months. So this is a real result on that large model that most people at Viasat know about. I'm just not giving you a name for it, but they all know about it. And so the results have been good. The results have been really good. So we understood where the breakages were in the process as we went through the workshop. We found a way to sort of stop those breakages and link them so that the ML life cycle flows through the process, through the orchestration, through the platform we designed. And you can see the results. The results prove themselves that we did fix the key issues in the company, right? It's not that we were bad data scientists. It's just that we were having trouble maintaining our models. And then that's just one area. You saw the gamut of use cases that we have. So a bit more sort of generalized results, right? That was the specific MVP, which was important to prove. But more generalized results. I think we now have a standard and scalable environment that we can truly sort of say that we can do a lot of machine learning, and a lot of these repeatable tasks around putting those models in production are taken care of by the platform. The integrations, the authentication, et cetera, integrating with our data sources, code repositories, model registry. When do you register something in the model registry, et cetera? Those are all kind of taken care of. So a lot of dirty work has been done. It's scalable, serverless. And then the templates, like one of the template examples I showed you, these blueprints have now been created, right? So we store them, and then these are standard across all our businesses. You saw the different markets we serve. We can apply these templates across all those markets as far as data science use cases are concerned. What else is worth calling out? I talked about this already. So we now have knowledge in the company about SageMaker, about MLOps, DevOps practices extended into machine learning operations, et cetera, right? So a lot of best practices emerged as we did this work, and I think we feel comfortable that we now have the DNA to take our models to production quickly. And then platform got created, which was important. This platform. There was one other thing I didn't talk about. We have also very, I would say, diverse kind of scientists. Some only want to code in R. Some only want to touch TensorFlow. Some only want to work with PyTorch. I don't know why that is the case, but that is the case in our company. And I think this platform now caters to all of them. So that was another point of contention in our approach to building a platform, was that everybody had these different ideas about what it needs to do and what it needs to look like. So we think that we have a harmonized solution where the framework you work on doesn't matter, the language you code in doesn't matter, et cetera. And then the last bit of it is that given the number of staff data scientists we have in the company and the operational staff, they are also, I think, data engineers or machine learning engineers, but we call them MLOps, or the guys who take care of this platform. There are only 4 of them for the entire company. And so I think that ratio is good. I think it's very good. I don't know elsewhere, what your companies look like or what your ratios look like in terms of MLOps to data scientists, but I think it's a good number that we've achieved. So we're happy about that. And then finally, I think this process, this transformation has been useful and successful, and we have more work to do, of course. As I said, satellite networks, the bandwidth that these networks offer now, they're all increasing. I mean, if you think about some of our satellites, in hundreds of gigabit per second ranges, the newer ones support a terabyte per second. So things are changing really rapidly. We're pushing the boundary on the bandwidth and the efficiencies. But we need to keep the network and this hybrid overlay moving as well and react at the same speed. So I think changing our platforms, batch inferences where they happen, all of that to real time is critical, given how this industry is evolving. So, for the lack of a better word, I'm just calling it live ML, but that's what we need to do, right? The root cause analysis, which is automated, the remediations I talked about, that is automated. A lot of that requires a very real-time data platform underneath. And so we need to do that. And the machine learning and our models and our MLOps practices need to evolve with that. So we're working on that. I don't think we still have conquered the large-scale ML pieces, the classical sort of machine learning several years ago, if you guys are familiar with, the parameter server-based approaches, et cetera, where, you're doing approximation, but since the model is trained on such large data set, it's good enough, probably better than other approaches, complete approaches. We haven't cracked that code yet, so kind of call it big ML, et cetera. I think we need to get better at that. And then, of course, no conference, no talk is complete these days without talking about generative AI. So I think we have done early work from the last year or so on developer productivity type use cases with generative AI. I think they've been pretty successful, very well received in the technical communities in the company. But I think we need to take a lot of those and move them into field use cases, production use cases, which requires us to get good at prompt engineering, which we're not today, right? So I think that's yet another DNA that needs to come into the company. And so we've started some work on that. Some of the announcements you saw yesterday, I think was exciting. Bedrock and Q, et cetera. So we'll start looking into those. And that's the beauty of our AWS partnership. As we're thinking about a lot of these things, have approaches, AWS is coming up with these services. So we'll start looking into those and see the approaches that we have or the approach AWS has put together is better. So we'll work on those. With that, I'm going to hand it back to Andre.
All right. Samit, I want to thank you for sharing your powerful story of how you're using AWS to standardize and really scale an ML ops platform out to all the data scientists across your company. And also, it was amazing to hear how you've been able to cut the time of your deployments from hours down to minutes through your approach. So that's really powerful. And Claire, thanks for getting us kicked off with this session and focused on what we're focused on from an AWS perspective every day, and that's the customer. So let's give our speakers another round of applause.
Thank you.
So to close things out, we want to share these follow-up resources for you, these QR codes, to learn more about the story that was shared today and discover other use cases that may be relevant to you all. And so with that, I'd like to say thank you. And now we'd like to open up the floor for questions